Imagine, a tiny spacecraft ventures forth. On November 5, 2018, a historic moment unfolded. Voyager 2 crossed a monumental threshold. It punched through the outer boundary of our sun's influence. It entered the vast, mysterious realm between the stars. This was not just a scientific achievement, it was a profound leap for humanity. This little probe became an interstellar ambassador. It confirmed its passage by detecting a dramatic change in its environment. The solar wind suddenly dropped. Simultaneously, cosmic rays surged. These were the telltale signs. Voyager 2 was no longer cocooned within the sun's heliosphere. It was flying free, in the space governed by other stars. Think about that. A journey of billions of miles, culminating in this quiet, cosmic crossing. Voyager 2 became our first direct sampler of this primordial cosmic soup. It's a place far colder and stranger than anything within our solar system's familiar embrace. The significance of this event cannot be overstated. It is a testament to human curiosity. It speaks to our relentless drive to explore, to understand our place in the cosmos. The story of Voyager 2 began long before its interstellar leap. It launched on August 20, 1977. Its mission was ambitious from the start. It was designed to undertake a grand tour of the outer solar system. This was a rare opportunity, a planetary alignment that occurs only once every 175 years. Such an alignment would allow a single spacecraft to visit all four gas giants: Jupiter, Saturn, Uranus, and Neptune. Voyager 2's trajectory was a masterpiece of celestial mechanics. It flew by Jupiter in 1979, Saturn in 1981. Then, it uniquely continued on to Uranus in 1986 and Neptune in 1989. No other spacecraft has visited Uranus or Neptune. Each planetary encounter was a revelation. Voyager 2 unveiled swirling storms on Jupiter, including the Great Red Spot in stunning detail. It explored Saturn's majestic rings and its diverse collection of moons, like Titan with its thick atmosphere. The key to this grand tour was the ingenious use of gravity assists. As Voyager 2 approached each giant planet, it used the planet's gravity. This was like a cosmic slingshot. It altered the spacecraft's speed and trajectory, flinging it towards its next destination. This technique saved enormous amounts of fuel and time. Our sun is not just a source of light and heat, it also creates a colossal magnetic bubble around itself. This bubble is called the Heliosphere. It is formed by the solar wind, a constant stream of charged particles. This plasma flows outwards from the sun at supersonic speeds. It travels far beyond the orbits of the planets, carving out a vast region in interstellar space. The heliosphere is our solar system's home in the galaxy. It is our shield, our local cosmic environment, shaped and defined by our star. The heliosphere is not a simple, uniform bubble. It has a complex structure with distinct boundaries. As the solar wind travels outwards, it eventually encounters the interstellar medium. This is the gas and dust that exists between the stars. The first boundary it meets is the termination shock. Here, the solar wind abruptly slows down from supersonic to subsonic speeds. Beyond this lies the Helios heath. This is a turbulent, transitional region where the solar wind is further compressed and heated as it interacts with interstellar matter. Whispers from beyond. Data from the interstellar medium. Even after decades in the harsh environment of space, Voyager 2's instruments continued to function. As it crossed into interstellar space, its sensors began to paint a new picture. They started sending back data about a region never before directly sampled. These were the first whispers from the interstellar medium, the stuff between the stars. This data was, and continues to be, incredibly precious. It's our first on-site report from the galactic neighborhood. One of the key instruments, the Plasma Science Experiment, or PLS, made a crucial detection. It measured the properties of the interstellar plasma. The data showed that the plasma in interstellar space is significantly denser and colder than the plasma within the Helios heath. The solar wind plasma had effectively disappeared, replaced by this new, different kind of ionized gas. This confirmed that Voyager 2 had indeed left the sun's domain. It was now sailing through an entirely new cosmic sea, a sea made of ancient atoms. A mirror to other stars. Implications for astrospheres. Our Sun is just one star among billions in the Milky Way galaxy. And just as our Sun creates the heliosphere, other stars create similar bubbles. These are called astrospheres. They are the stellar equivalent of our heliosphere. Each star with a stellar wind carves out its own domain within the interstellar medium. Voyager 2's journey beyond our heliosphere gives us a unique template. It helps us understand these distant astrospheres, which we can only observe indirectly from afar. By studying the boundaries of our own heliosphere in detail, we gain invaluable knowledge. We learn how a star's wind interacts with the surrounding interstellar material. We see how the magnetic fields behave. We understand the particle environment. This information can then be applied to models of other star systems. It's like having a local laboratory to study a universal phenomenon. Voyager 2's findings are not just about our solar system. They are about how all stars shape their cosmic environments. Earth's calling card. The golden record aboard Voyager. Beyond their scientific instruments, both Voyager 1 and Voyager 2 carry something truly special. They each bear a golden record. This is a 12-inch, gold-plated copper disc. It's a message in a bottle, cast into the cosmic ocean. It contains sounds and images selected to portray the diversity of life and culture on Earth. It's a greeting, a story, a piece of ourselves, sent out to any potential extraterrestrial civilization that might one day encounter these wandering spacecraft. The contents of the golden record were curated by a committee chaired by the late, great Carl Sagan. They include 115 images, encoded in analog form. There are pictures of DNA structure, human anatomy, animals, landscapes, and scenes of human life. The record also carries spoken greetings in 55 ancient and modern languages. There are sounds of Earth, like wind, rain, thunder, birds, whales, and human laughter. And of course, there is music, a diverse selection from different cultures and eras, from Bach to Chuck Berry. The purpose of the golden record is one of hope and connection, the enduring legacy. Voyager's endless voyage into the galaxy. The Voyager missions, Voyager 1 and Voyager 2, are more than just successful space probes. They are legends. They have fundamentally reshaped our understanding of the solar system and beyond. They pushed the boundaries of exploration further than ever before. They are icons of human ingenuity, perseverance, and our unyielding quest for knowledge. Their journey from the inner solar system to the interstellar void is one of the greatest adventures in the history of exploration. They are true pioneers. Their journey is far from over. Though their power sources are dwindling, they continue to glide silently through interstellar space. They are moving at incredible speeds, covering vast distances every year. They will wander the Milky Way galaxy for potentially billions of years. They will outlast us. They will outlast the Earth as we know it. They are our silent, enduring emissaries to the cosmos. Their continued existence in the void is a humbling thought, a reminder of the vastness of time and space. The scientific legacy of the Voyagers is immense. They provided the first detailed look at the outer planets and their moons.